Welcome, Glauber Costa.
Thank you. Thanks for having me.
Yes, so you're the CEO of Terso, and you're rewriting SQLite in Rust.
We are. Yes.
Why do that?
Well, it's a great question, and a lot of people focus too much on the why Rust, and just to get it out of the way, I don't think it truly matters. You could have done it in any language. I mean, we happen to like Rust. I know Rust. We wrote a bunch of stuff in Rust before, both Becca and myself. It's a safe language. It's a nice language. It's a language that is, I think, gaining. It has a lot more maturity than, for example, Zig, and it's more ergonomic than C++. But the project could have been done in any language. But the reason we rewrote SQLite, we wanted to rewrite SQLite, is that we see the world changing very rapidly now, and we started this project officially around a year ago. It's clear that with agents and with AI in general, there is a need for a database that can scale in a new dimension that just wasn't a thing before, which is just a sheer number of databases, right? So you can scale in how fast your queries are, you can scale in the amount of data you can store, but you also now has to scale in just how fast you can spin up a database and how many of those databases you can have. And this is, again, because every one of those applications that AI generates, it needs a database that is very cheap. You don't know if this application is going to work or not yet, so you need a database that just works like that. And even for those applications who do work, they come online and offline. They're not always running, so they have a very different pattern than what we've seen so far. We saw that SQLite fits that bill perfectly. SQLite has the right shape for that puzzle. Right? It's just a file, you don't pay anything, it's just sitting there, and then you can back it up later if you want. But it doesn't have the capabilities that we think are going to be needed. It doesn't have concurrent writes, it's not an asynchronous interface, which means it's hard to run it on the browser. There's a large variety of things that people seem to want out of SQLite, but it doesn't have. We could have contributed to SQLite. Becca and I and the team, we were very experienced in open source software, but SQLite is not an open community. They don't have a community in which you can just show up and bring your contribution. So the decision that we made was to rewrite. And again, the Rust part is the least interesting part of that story.
So just following along on the sort of the agentic workflow side of things, what are some of the use cases that you're seeing? You can perhaps talk about how you're building a file system on top of Terso and how that plays into Terso Cloud and the syncing into sort of like that infinite disk concept.
There are three main use cases that we see a lot today with our database. The first one is the database of record for applications, much like you would have either a normal SQLite file or a Postgres or a MySQL database, with the exception that you now have billions of them. So for example, if you are a vibe coding platform, or if you have your own agentic infrastructure internally in your company, you're generating applications at a pace that just wasn't possible before. Each of those applications has a database. This database is isolated. You don't put all of your applications to talk to the same central database. And we see that, again, Terso, SQLite in general, Terso in particular, has the right shape for that whole. So we've been seeing a lot that we have companies like Val.town who are customers of our cloud, and that's what we do for them. Every time they run a function, if you want, you can have your own isolated database just for the workloads that function executes. We call this hyper-tenancy, which is, again, just the idea that you're going to have data massively split across databases. That's use case number one. Use case number two is just like storing data that the agents are generating in the process of generating those applications. So that would be the context, the chats, the agentic memory, so to speak. Usually agentic memory has layers on top of the storage. So you can search, you can treat, you can pick which piece of information that you want to use. But when you talk about the storage layer, Terso sees some penetration there as well. Again, just because every session can have its own database. And the third use case is one that you mentioned. We've been hearing from a lot of people. What I truly want is just a file system. I just want a place to store my files. And It would be great if I had a file system, but which sometimes you do, sometimes you don't. And serverless you don't. If you're deploying this on Kubernetes or in some sandboxes you do. But you want the file system that is disaggregated. You want a file system that is it's always online and it has extra capabilities because those agents make mistakes. You want to be able to snapshot. You want to be able to branch a file system, give that state to a sub agent. You want to be able to roll back. So all of those things, they map very well into a SQLite file because you can have all of your files in multiplexing the SQLite file. And a branch is just a copy of the SQLite file, right? The rollback is just moving to the previous file. So we have a project called AgentFS, which is agentfs.ai, which is essentially that. I mean, it gives you an entire file system interface that is built into, on top of a SQLite file, powered by Turso, and that is also one of the 3 major use cases that we see a lot.
So let's change tracks and talk about how you've, been developing Turso. So you talked about deterministic simulation testing and your use of antithesis. How does that help you to sort of get through all of the edge cases? My understanding of building databases, which is next to zero, is that there's millions of edge cases that can pop up. And how does this whole process help you to, I guess, make a much more guaranteed?
And it's more than the edge cases. I think it is the consequence of the edge case, which is usually like your data is gone, and usually that's not something that people get very happy about. And I built both databases and file systems in my career, and there's a saying from the file system world, which is it's going to take between 5 to 10 years to stabilize a file system. So when a new file system would come into the Linux kernel, we kind of had the expectation that fine, I mean, we're going to merge it now, but people are going to start using it in 5 to 10 years. So, it just takes time, and deterministic simulation testing can squeeze the timeline. I mean, databases are not different. It takes a long time for you to get to the level of trust in a database because, again, the failure mode is not just that it crashes. The failure mode is that it may destroy your data. So you need to be very careful with that. And deterministic simulation testing is a technique that we've been using successfully. It combines fuzzing with property-based automatic test generation. So you don't write tests, not in the sense that people are used to talk about tests. You have properties of the system, and then you automatically generate tests that will stress and validate that property. The beautiful thing about deterministic simulation testing is that it will give you deterministic guarantees. So if something fails, you can just replay the session and everything that happened, reading timestamps, doing I/O, calling the file system, everything will come back the same. So if there is a problem, so it helps you find the issues because it will explore automatically the space of possibilities. But when an issue is found, you essentially can solve it in perhaps less than a day versus weeks without the technique. And we have some examples in which we found issues like that. I mean, and you find something, you're doing something with that, the database corrupts your data, or there's something very bad. In the past, in my experience, I mean, writing file systems 20 years ago, databases 10 years ago, is that you have to go into this mode of thinking, how did we get into that situation? And it's very hard to reproduce those things, but with deterministic simulation testing, what you do is that you think, okay, why did the simulator didn't catch that issue? So, maybe the simulator is not generating, you formulate a theory, maybe the simulator is not generating compound indexes, and I had a compound index, so that might be the case, and then you just expand the simulator to test, to cover the ground that it wasn't covered before, and then you find 5, 6 different bugs, and they reproduce perfectly. So it's a technique that we use to make sure to provide the guarantees, to be able to confidently say to the world that we rewrote the most reliable piece of software on earth, which SQLite is acknowledged to be, and you can trust the result.
So a lot of what you're talking about is super technical, right? But you explain it in such an understandable concept. Your technical blog about I/O Uring became a surprise hit. What have you learned as a result about communicating complex systems concepts?
It was, that blog is an interesting one because that one was a surprise hit. It was a surprise hit in the sense that when I was at Scylla, I wrote a lot of blog posts, much more than I do today, just because, my job is very different today. I still write a lot, but not at the pace that I used to. And I could never, I had many hits. I think that was the biggest one, but I could never predict which one would be a hit and which ones were not. And that one in particular, I almost gave up. Halfway through, I say, no, nobody wants to hear about this. And then it's probably one of my best hits to date. So in that sense, it's quite surprising. But what connects all my writing is that I think that people have the tendency when talking about complex subjects to say, there's so much I can talk about this, and the goal of my writing is to explain all of this to you. And I come from a different perspective. My perspective is like, it's very unlikely that anybody will understand everything, and it's very unlikely that everybody is even interested in the whole dimension of what I have to talk about anyway. So I'm going to pick one thing, and then I'm going to focus on that one thing. And I think a lot of people in technical writing truly have this tendency of, and first of all, your instinct, especially as an engineer, is to tell a story of how you got to that point.
Yep.
And by the time you get to the point, then you lost the reader. And you want to be able to, along the way, show all the amazing things that you can do, because this thing can do amazing things. I approach it very differently. I usually start from the end. Here's what I want to tell you.
Yep.
In the first paragraph. And I might mention other things if I see an opportunity, but when I'm writing an article, a blog, or any technical material, I usually have a very specific goal. I want the reader to understand this one thing, and then everything goes around that axis. So I think it helps a lot because it simplifies, takes things that don't matter out of the way. And it's been working. I mean, it's been working for me for a long time.
Nice. Well, really appreciate your time, Glauber, and all the very best.
Thank you,
Cheers.
Peter. Enjoy.
Thank you.